Okay, we're going to go ahead and get started with next session. I'd love to introduce Ido Shilon, who is a team lead at LivePerson.
Hey, good morning, everyone. I'm Ido Shilon. I'm heading the platform engineering group at Lifeperson. At Lifeperson, our mission statement is to connect between brands and customers. We're going to hear about it in a few minutes. You're going to learn today how Couchbase help us in transforming our architecture and how it might be applicable to you. In this specific story, you're going to learn how we use Couchbase and other NoSQL technologies to build a highly scalable real-time analytics system. So I'm going to take you through a little bit what is LivePerson, what was our journey, what problem did we encountered, and how we used Couchbase to help us resolving this issue. And maybe some tips and tricks that we learn along the way, again, it might be applicable to what you guys are doing. So as we said, LivePerson, we call it connection before content. So a few facts about myself. You know my name already. I have a daughter and one wife. The kids is an array, the wife is not. So hopefully it will remain this way. And I had the privilege to live and work in the top 3 tech hubs in the world. I started my way back in Israel, and I had the opportunity to work in the Bay Area for 4 years. Also had the opportunity to work in the Silicon Alley in New York for a little while, quite a different experience, I must say. And a year ago, I came back to Israel, and I joined LivePerson. So some information about LivePerson. The one thing that I want you guys to remember is, again, our mission statement is creating meaningful connection between customers, between brands and the customers. We are an engagement platform. We've been around since '98. We've been doing SaaS since '98 when it was called ASP, if you guys remember that. We have around 8,500 customers. 8 of the top 10 Fortune companies are LivePerson customers. So let's move on and understand what is an engagement platform. So this is an example from one of our customers, Verizon. So you see here a visitor that essentially reached a checkout page on the Verizon website. Our system identified that this particular visitor is lingering on the checkout page, and we display essentially a message to the visitor. And upon clicking on that message, we allow the visitor to start engaging with an agent, the customer representative of Verizon on the other side. And essentially, this agent helps the customer in closing the sale. So in LivePerson, we're all about what we call the incremental lift. We're trying to reduce the bounce and increase conversion. That's essentially what we do. Let's go to the interesting stuff, the technology. So a little bit about ourselves. We're really heavy on the JVM side. Most of our code is in Java and Scala. We have our own private cloud based on OpenStack. We have 4 different data centers around the world. 2 in North America and 2 in the EU. Just so you understand the scale of LivePerson, the thing that we do. So a few numbers about our data, the volume. The interesting numbers over there are we do about 1.8 billion different sessions a month across our network. We're actually creating 20 million different types of engagement every month. And we generate somewhere in the range of 13 terabytes of compressed information that's being dumped to Hadoop every single month. In order to support this scale of information, in order to process this scale of information, we had to build a full data stack, different technology to deal with different problems of processing this information. You can see in the next slide, you can see essentially a map of our data stack. So on the top, you can see essentially the 2 services, the 2 LivePerson services that actually generate this information. Our monitoring piece is essentially a web tier that actually listens to what the visitor is doing on our customers' website and mobile devices. And the chat and the voice systems are actually the engagements themselves, the chat that you create with the rep, or the conversation that you have over the phone with the rep. We're heavily relying on Kafka, Apache Kafka, which essentially was invented in LinkedIn. We use that as our major messaging bus. And we have what we call the two tracks. We have the batch track and we have the real-time track. On the batch side, we're heavily, of course, relying on Hadoop for all the offline processing. And on top of Hadoop, we're using also Vertica and MicroStrategy for an analytical database and BI. And the interesting stuff on the right side is what we call the real-time track. And we are using Storm in order to do complex event processing. And in the beginning of the year, before we added Couchbase into our arsenal of tools, we use Cassandra as our main real-time repository. So I want to take you through the actual use case, the actual problem that we had, the product that we're kind of looking at right now, this particular use case. So a couple of minutes ago, I showed you the Verizon website where you saw the visitor and then the engagement with the agent. So that was the visitor side. What we're doing, we have a product we call the web agent, which is essentially a console that's being used on the call center side, where, let's say, in this particular example, the Verizon agent sit and essentially communicate with the customer on the other side. So this is a screenshot of that particular of this particular product, what we call the web agent. It's been used by tens of thousands of agents in call centers all across the world in every given moment. This particular subsystem that I'm going to present today is something we call the visitor feed. Essentially, it provides the agent the visibility of their concurrent visitor all across the digital properties. It could be on the website, it could be on the devices, and essentially give them a real-time analytics view of their online customers. And each one of our accounts, each one of our customers has its own view of the actual customers, where they're browsing, where they came from, what browser are they using, different type of custom integration that we're doing with our enterprise account, and so on and so on. So essentially, and I'm going to show it in a second, we're using Couchbase in order to store this real-time information. So before I'm jumping on to the actual solution itself, I want to take you through our journey. This is kind of a snapshot of where we started. This is what we call our legacy system, which was built in the past 10 years or so. So in this particular example, in our kind of legacy information, we have the visitor on one side, and we have our web tier that collects the information on the visitors all the time. Those servers are essentially kind of a monolithic system that aggregate all the information on the visitor. It's a stateful server. All the information on the visitor was kept in RAM. So we couldn't do any horizontal scale. We could only do vertical scale, and that can scale so much. And on the other side, this is the agent console. The legacy agent console was a Java application, essentially, that communicate with that particular server. Every account of ours had its own server, and essentially communicated with a proprietary protocol and got all the information about the visitors that was stored in that particular server RAM. So that's where we started, and our major problem with that was the fact that we cannot do any horizontal scale. We encountered scalability issues, and about a year ago we started with the process of re-platforming our entire system. So the new architecture is essentially a kind of a service-oriented architecture, distributed system. You see now that essentially every customers of ours uses a clusters of servers, shared clusters of servers. We also wanted to get to a point where we can move into what we call an active-active mode, which is essentially one website can be served by multiple data centers. So this has increased the complexity of the solution, of course. And as I mentioned before, we're using Kafka as a messaging bus. So all of the events, all the states of the visitor, everything goes down and streamlined into the Kafka. And we use Storm to process those events. The problem that we are on the other side is, since it's a distributed system, it's multiple data centers, we had to store all the information about the visitors, all of the real-time information about the visitor in a single repository in order for the web agent to query that piece of code, an API in this case, and get the real-time information from all across the data centers, from all the clusters, from all the servers at once. And when we got to this point somewhere in the range of beginning of the year, we kind of designed the system, and we got to this point. And at that moment, we essentially had an evaluation of different solutions, different NoSQL solutions. We considered 3 main options. I'm sure the Couchbase guy's going to like the next 2 slides. So as I said, Cassandra, we know Cassandra fairly well. We've been using Cassandra for 5 years or so. We know what works and what doesn't work with Cassandra. It's a reliable system. It's a great product. All of them are great products, by the way. So Cassandra is the first option that we looked at. We also looked at MongoDB. As I told you, I used to live in New York, and if you guys are part of the New York tech community, you know that Mongo is everywhere in New York. Everyone are using Mongo. They're doing a great job with the developer community over there. So I used Mongo. It's a great tool, and that was one of the options that we looked at. And of course, Couchbase. We met the Couchbase guys 10 months ago. We knew about Couchbase, and then we started to look and dive into that option as well. So I just want to share with you kind of a high-level comparison that we did with those 3 options. This is a snapshot. This is not the entire comparison, but it summarized the requirement that we always had. Linear scale was a very important consideration for us. We wanted to use a document store. We wanted a flexible data model. And I think the 2 most important lines in these slides is actually the high throughput. In our particular use case, this particular system has a very high throughput of read and writes, mainly writes and mainly a lot of updates, because every time the visitor is interacting on the website, we get a new event, new information, and we need to keep updating the same document. So high throughput was probably the most important criteria in this regard. And when we did some testing, we took some benchmark, we did our own testing, we found out that from these 3 options, the only one that fit our requirements was Couchbase. One other thing that Deepti has actually mentioned before, the cross-data center replication, given the fact that we went into an active architecture, was a really important criteria for us as well. So I want to take you, kind of give you a view of this is the architecture of what we call the visitor feed. Again, the service that provide visibility in real time for all of the agents that using the system. So this is kind of a high-level architecture, and I'm actually going to start from the bottom up. So as I said, all of the events are being streamed into Kafka. We use Storm topology to process those events. It's running in let's say in the US, it's running in 2 different data centers, one in the east, one in the west. We're essentially pushing all of that information into Couchbase. So the only place that we actually do writes and updates into Couchbase is through the Storm topologies. That pushes it into a Couchbase cluster. We're using, of course, the views to generate secondary indexes, and I'm going to explain a little bit more afterwards. And on the top, you can see essentially that service exposed a REST API that's been used by the web agent console. And that REST API is essentially a Tomcat Java app to use the Couchbase Java SDK and essentially query, every few seconds, it's query Couchbase to get the latest and the greatest regarding the information. And I'm going to show you a different view of this slide, and it's essentially kind of what we call a data view. So, every time the user is browsing, doing an interaction on the website, or it applies, when I'm saying website, I'm also applying to mobile web and even native apps. So everything relates to the same thing. So we have our own monitoring service. Essentially, every customer of Lifeperson embed a JavaScript tag on their pages, and that monitoring service is the one that get all the heat, get all the information all the time. That system essentially stream the events, the information down to Kafka, and goes into Storm for analysis. Like I showed you before, it pushes it into the Couchbase cluster. And on the other side, the API, the agent use the API, and every few seconds get the latest information from Couchbase. So for us, the writes are very important, and also the indexes are very important because we use the indexes a lot. I'm going to speak about data modeling for a second. So I mentioned it before. In our use case, every document represents an active visitor. It means when a new visitor logs into a website, a new document is being created. And also it means that when a user leaving the site after some timeout, essentially we need to remove that document from Couchbase. It's kind of one tip that we learn along the way. If you guys are doing a lot of deletes, try to use the TTL method versus the delete. Couchbase knows to manage the deletes in a much more efficient way if you're using the TTL. So that's kind of a small advice. We're storing in at the document level. We're storing session level attributes. So everything that we know about that visitor in that particular session, again, where they came from, what browser are they using, what pages did they browse, and so on. We also have a really deep integration in some cases with the customer website, so we get a lot of customer attribute on that particular visitor, and everything is being stored in the document. I said before that Lifeperson is a SaaS platform, so this particular bucket is also a multi-tenant bucket. Just from the number perspective, an active document is somewhere in the range of 10K as far as size, and the character that we're using, the key size is around 10 characters as well. And those numbers are really important when you get into sizing. We use the views I mentioned before. We use the views for secondary indexes, so every document that gets in need to be indexed, and it's usually been indexed by of course, the account ID, the timestamp, and the state of the visitor. We keep states of visitor, if they're browsing, if they're chatting, if they're waiting for a chat. So all of those states are being essentially indexed as part of the indexes. Right now, we're using the view function, but we don't use the reduce function. Our plan is to use a MapReduce later down the road to create also statistical views of the information. So in this conversation, I mainly mentioned the agents, which are actually the people that takes the call and communicate with the visitor. But you also have a shift manager, and you have the call center managers, and their point of view is a little bit different. So they want to see statistical information and analysis of their online visitors. So I'm going to give you a kind of a snippet of a document. So this is a partial document from the system. As I mentioned, we are a multi-tenant database, so you see the account ID. You see the basic visitor information. And you see in this document a lot of sequences. So if you are using Kafka, I don't know if people in this room are actually using Kafka, but one of the things that Kafka does, it actually doesn't guarantee you that the events will get in a sequential way. So you might get them in a mixed order. So it's really important to use a sequence or a timestamp to know if the event that you received is older than the event that you already processed. So we use a lot of sequencing, and we actually rely on Couchbase to store those sequences. Instead of having like a local cache, we actually rely on get and set from Couchbase in order to understand the order of the events. So I mentioned cross-data server replication. In our case, we actually use bidirectional replication in order to achieve the active-active. Our initial deployment, just so you guys get kind of numbers of servers and everything. When we started this project and we aim for our alpha product, we have 4 data centers in the world, so each one of them contain, essentially hold a cluster of 3 nodes. This is kind of the basic requirement. And we have kind of 2 different zones in the replication. So we have 1 replication in the EU and 1 replication in the US. In our design, the key space is shared among the 2 clusters. So we kind of avoided conflict in that regard. A document is going to be written either, let's say, either in the East Coast or on the West Coast. It's not going to be written, the same document is not going to be written at the same time into the two different clusters. So that saves us a lot of kind of conflict resolution. And Deepti mentioned that before, but replication has a lot of impact on sizing, mainly in the target cluster. But when you do a bidirectional replication, you essentially have source and target. Each cluster is both source and target. So there's an impact on sizing when you're planning to work with a bidirectional replication. So I want to show you a screenshot of actually a screenshot that I took a week and a half ago from our production environment. We didn't get, right now, we're not fully deployed yet in the sense of all of the traffic of Lifeperson go through the system. We did an alpha test, and now we start rolling the traffic into our beta customers. So you see in this particular screenshot, you see somewhere in the range of 20,000 ops per second. This represents somewhere in the range of 10% of our overall traffic. So even with just 10% of the overall traffic, we reach 20K events per second. That's a lot. Again, this is running on a 3-node cluster. Each one of the servers is what we call extra large. It's not an EC2 service. We're running our own data centers. So this is a 64 gigabyte RAM, the servers with 24 cores. So those strong servers, and the system, at least initially, is working fairly well. The set operations is sub-milli for now. That's what we see in the response time. As far as the CPU, everything seems okay, but the important metrics to view in this regard, if you're already using Couchbase, is the disk write queue. Because right now the way that we work, we rely on views, and the document need to be persistent before it appears in the views. So we're kind of monitoring that particular metrics to see when we need to add more servers to the clusters. I must say that we worked really close with the Couchbase team, both Deepti and the support guys, to help us understand if the architecture that we prepared is the right one. And they helped us a lot when it comes to sizing. It really was helpful for us. So a couple of things that we learned till now, and I'm sure that some of those are you guys familiar with that. So test in production. When we start designing the system, we had some assumption regarding the workload, regarding the sizing. When we put things in production, fairly well, we put things in production after a couple of months, and we found out that some of the assumptions we made weren't the right one. It's always the difference between theory and reality. I urge you to start testing in production as soon as you can. My advice is you should follow the Couchbase sizing guidelines. So some of the key inputs that you guys need to remember are definitely the document size, the key size, the replica factor. We use right now replica factor of 1. And data center replication, of course, has implication on the sizing. And when it comes to scalability, especially with our system, which is the work set is close to 100% in our case. So RAM and probably SSDs are key factors in scalability. So I want to show you this, the same screenshot that I showed you a few minutes ago. And I'll show you where we consider to use Couchbase right now. So with Couchbase, it's definitely being added to the real-time repository. That's what we're going to use Couchbase for mainly. We also think that Couchbase can help us on the analytical side, given in real time it has MapReduce views, so we can use the reduce function to start creating aggregation of the information. For us, Couchbase is a strategic choice. We're looking on using it, as Dipti mentioned before, as a visitor session information. We want also to use it as a cross-session state, so server-side cookies, essentially. It's the fact that it's a fast read and write persistent storage is key for us. We have a lot of heavy load read and write apps, so we need to rely on something, and we're most likely going to rely on Couchbase. And the fact that it has a built-in memcache is also always a sweet spot for us, because sometimes you just need a generic caching layer, and the fact that we can use memcache is great for us. So before I'm concluding, I wanted to, first of all, if you guys have any question, I would love to take. Cool. Yeah.
You mentioned about analytical part. You already implemented or you plan to implement?
What? Sorry?
Analytical part.
The analytical part, no, it's something that we have on our plan. We did few POCs, but we just created some MapReduce or reduce function. We're not actively use it in production as analytical. That's one of the directions we will take a look at. Okay. I need to check. I don't remember, but I can find out. By the way, by Cassandra, the main reason we actually didn't go with Cassandra is the fact that you can't, I think, I don't remember to but the fact that it's not a flexible schema in the sense of document store. And we wanted to do a lot of queries, and we wanted to use the views. I didn't want to develop the queries myself. I wanted to rely on a query engine. And that's the main reason we didn't go with Cassandra. Okay, interesting. Yes.
You mentioned about the sequencing.
Yeah. Yeah, we kind of store the sequence that we get in Kafka, and then we know to compare if the current event. Yeah, we don't rely on in the sense of creating sequences, but just storing the sequences as a fast cache as well to compare. Yeah, we have the event system that essentially put a timestamp for every event, and that's a sequence. Yeah, but if you're using Kafka, one of the kind of design guidelines of Kafka, it doesn't guarantee a sequential event, so you have to deal with it somehow, especially in the real-time system. If you do an aggregation, like an offline aggregation, then it's not a problem because you have all the event. This is more for a real-time system and a real-time dashboard, so the requirements are a little bit different in that regard. Yes, sir.
You mentioned the SSDs. Are you putting your views on the SSDs, or are you putting the views and the data on the SSDs?
So the current cluster is a hard drive. We didn't move to SSDs. We're going to do it in a couple of months from now because we're just kind of testing the large scale. Right now, we're definitely going to separate the views and the data. So it's going to be a cost factor. I think views probably are more important for us in that regard. So we'll do views on the SSDs for sure. We'll see about the data. I know that I think one of the features that Couchbase are going to deliver, I don't know if it's the end of the year or early next year, is something they call the consistent indexing. So it's the ability to create an index also based on what you have in the RAM versus the persistent documents. So this might change the picture a little bit. We're actually waiting for that feature to roll out soon. So, yes, sir. What's that again, sir? Right. It is a concern, as I mentioned before, as far as latency, because most of the, actually all of the writes are done asynchronously. We don't see any latency. In our measurement, even with 20K ops per second or 3-node cluster, still the response time is sub-milli, so we don't see that. But as I said, the important metrics in that regard is the disk write queue. For now, it's okay. I mean, we didn't see a problem, but I'm sure that when we're going to scale, we're either going to need to either accelerate the move to SSDs or add more nodes. So that's definitely a concern. That's our biggest, the one thing that we monitor all the time is the disk write queue right now. Yes?
What's the rationale for active-active replication, and what kind of impact the scale of
Okay, good question. So the rationale behind active, so as Lifeperson, we want to serve visitors from the closest edge to them. So that's why, let's say on the Verizon example that I showed a few minutes ago, if you log in into the Verizon website and you're based on the East Coast, we want to serve you from the East Coast, and if you're based on the West Coast, we want to serve you on the West Coast, right? So let's say there is one visitor on the East, one visitor on the West. But if you, the Verizon agent in the call center, you want to see a picture, you want to see them both, right? Because you want to understand it, you want to get the full picture. I'm just giving a very simple, very simple example from way more complex, very complex problem. But that's the rationale behind the active, essentially.
So
And, sorry.
that means that any time both east-west people are talking to each other,
Mm-hmm.
that they have active connections to both sides?
No. What I meant is, so we in the backend we collect the information, right? So let's say you logged into the Verizon website on the east, and I'm logged in into the Verizon website on the west, right? But the agent that sits in the call center, in his view, you want to see both customers. So we collect that information in the Couchbase in one data center. We have the other visitor in the other data centers, but we want to cross-reference those two visitors because we want to get the full picture. One account, the information for one account reside in multiple data centers. Now, as far as impact, it's mainly sizing right now. So we noticed that when we did planning, we noticed that we need to, for example, if our original planning was, somewhere in the range of 5 nodes, we needed to add 3 more nodes if you want to, in each one of the cluster, if we want to support the bidirectional replication.
East Coast, West Coast, 2 data centers?
In our setup, yes, we have, yeah. And it's also, one thing that is a key factor is, of course, networking. So if you want to do VPN, it's a combination of performance and networking. Yes?
Usually performance number, how does the document size is 10K?
Yeah, these documents are 10Ks.
How does, so you guys measure, how does the document size impact the number?
Well, it definitely impact the numbers. I think the Couchbase guys will be able to give you a better answer than me as far as the analysis, but it's one of the key factors in the equation of sizing. Yeah.
What kind of disk you are using?
What's that, sorry?
What's the I/O performance of your disk?
Okay.
Usually the low disk is 50 megabytes per second. What kind of disk you are using?
I can get the exact spec afterwards, but I don't remember the exact hardware spec. What's that? No, I don't. I am not 100% sure, but I can find out. Yeah. And some other question that we got from people. They ask us how easy is it to develop against Couchbase, and I must say that it was fairly easy. The initial concept, the POC, took us the entire system end to end. Took us somewhere in the range of 3 weeks to write the storm topology and the Couchbase access. It was fairly easy, and we considered at first to use actually the memcache buckets because we actually do not need the persistency in that regard because it's a real-time system. The disadvantage of using the memcache buckets is the fact that we cannot use views. And again, it goes back to the Cassandra question. We really wanted to use views for queries instead of building our own views. So, any other questions?
So how many views you have?
One design document with 4 views right now, different 4 views. What's that? 4 different views, essentially, because every view is also sorting and filtering, so 4 different views at the moment.
How many documents so far?
What's that?
How many documents?
So It's about it's a good question. Our first assumption was that we're going to have somewhere in the range of 2 million active visitors, which represent 2 million documents. So that's give or take the numbers. That's our assumption right now. We just saw different numbers when we put it in production. Remember I said the difference between theory and reality is quite big. So I just want to thank you, and you saw the journey that we had, what problem that we encountered, and I must say, and on a personal note, that I think the Couchbase team helped us on the people level, and the technology, at least up to now, definitely proved itself. So thank you guys.